Radians, what do you have up here for me? Pi over 2. What about here? Pi. 3 pi over 2, and then we're back to 2 pi here. All right. Next question I got for you before we get going. Let me say I put an angle in the second quadrant here. And I tell you this is 60 degrees. What's that 60 degrees called again? Begins with an R, ends in efference. Reference angle, good. Could you find this angle now? Because that's what I need you to do today. Can you find that angle? How? 180 minus 60, yep. All right, not bad. Let me say I put one in the third quadrant now. And I tell you this is pi over 3. Can you guys find the bigger angle? Because we're going to be in quadrants 2, 3, and 4 today. So I want to make sure we can find, if it's in quadrant 2, okay, I do 180 minus the reference angle. But what if it's in quadrant 3? Now I'm going to do pi and not subtract, but add. And I put the reference angle in the wrong spot. Son of a gun. It's got to go with the x-axis. So I'll do pi plus pi over 3. Are you comfortable doing that? Different denominators. It's okay. We'll go over that today. And then finally, what if it's in the fourth quadrant? So say I have an angle in the fourth quadrant here. Let's say, I don't know, pi over 4. What's the big angle? How can I find the big angle? How do I find the big angle now? 2 pi. What am I going to do with the pi over 4? Subtract it, pi over 4. Okay? So that's what you're going to have to do for me today. Questions before I get to these 3? All right, ready to go? Calculator, got to have one. It's a must. It's a must. Calculator out. There's no way we can do this today without them. It's getting used right now, yeah. Sure. Okay, we ready? Let's get going. I'm taking number 1, take a negative 2, 0. Put it into polar. And what I mean by polar, again, quick review. R value and theta. R is the distance from the origin, the pole. That's what's going to go in for R. It's always going to be positive. Don't worry about putting in a negative one when you give me these coordinates. And theta, take a look, got to be in radians. All right, the angle measure's got to be in radians. So what I need you to do first is draw your own little ghetto graph right now, sketch, and put negative 2, 0 on it. All right, do your own sketch first so you can see where this is. Because I'm probably not going to have to tell you anything on this one. So go ahead, plot negative 2, 0, which should be right here on the x-axis. I don't have to show you any tricks here. I don't have to show you any tricks. Ready? What's the distance from the pole? It's always got to be positive when I'm talking distance. So 2, so the R value is going to be 2. And this is why I want to review this with you. What's this angle measurement in radians right here? In radians, what's this angle measure? What is it? Pi. So this point in polar is 2 pi. That's it. For that one anyway. It's going to get a little bit more difficult because it's not going to be on one of the axes. Okay, so you tell me the distance and then you tell me what the angle measured is in radians. All set there? Because now I got to take a little slower. Negative 1, radical 3. Graph it best you can. You should at least know what quadrant we're working in. All right, so go ahead, do a quick sketch. Negative 1, positive radical 3. Best you can. You should at least be in the right quadrant. That's what I'm looking for. Negative 1, positive radical 3. What quadrant are you in? Hopefully everyone's in 2. All right, somewhere in 2. I don't know where, but okay, we're in 2. And what was that? -1 radical 3. All right, down to business. -1. I don't. Radical 3 is positive. Y coordinate's positive. -x, positive y. Somewhere in the second. I could care less, honestly, guys, where you put it, but it's got to be in the second somewhere. You all right? Yeah, right. All right, yeah, I'm good. Yeah, darn right I am. All right, 10 days off. It's like no big deal. All right, first off, R value. R value is the distance. Ready? It's the distance from the pole to that point. So I need to know that distance right there. How are we going to get it? You're going to make a right triangle for me. You're going to make a right triangle for it. So go ahead, just draw a vertical line down. You should be able to fill in 2 values now. What's this value? What's this x distance right here? -1 or 1, whatever you want to put there. And then what about the y distance? Radical 3. And guess what we're going to bust out to find the r value? Pythagorean theorem. Okay, Pythagorean theorem. So we're going to say r squared equals 1 squared plus radical 3 squared. And then we're going to solve it. And that'll be my r value. So the r value is going to be found using Pythag. And r equals 2. All right, no big deal. What's the deal back there? Yeah, what about it? 2 is bigger than radical 3. Get your game back. Come on. Yeah, well, let's speed this up. Everyone all right on finding the r? Use Pythag. Okay, theta, we're going to have to work now. Get ready to grind a little bit here. Here's what I need. Theta is this angle right here. I need to know what that angle is. You could find it if you knew the, what do we call this angle here? Reference angle. All right, because I'll ask you guys that in a minute, but if you knew the reference angle, you could find that angle. All right, so how do I find the reference angle? Ready? This is old school, real old school. This is a right triangle, right? What side is the radical 3 if I'm looking from this reference angle? Adjacent, hypotenuse, or opposite? No, right here. Opposite. And what's the 1? Adjacent. Anybody remember which one out of the 3 I can use if you have the opposite and adjacent side? Nick, what do you have? Tangent. And it's always going to be tangent that we're going to use because you're always going to have the opposite and the adjacent side. So here's what we're going to do. We're going to go tangent of that angle, tangent of theta equals, what was opposite side? Radical 3 over well, that's my fault. I should have kept the negative there. Yep. Over -1. And I would be so proud if you could tell me how to find that angle now. Oh, here we go. Anything. Just keep throwing out stuff. You don't do, no. Everyone got your calc on you? Yep. Make sure you're in degree mode. Make sure you're in degree mode first. Yep, we're going to do inverse tangent, so second tangent. If you have a fraction template, that's fine. If not, you're going to have to use the division sign. And we're going to do radical 3 over -1. We okay? Now that says negative 60, but reference angles are always positive, so this angle is going to be 60. Now, time out. I don't want to go too fast here. Questions on how we just found 60 degrees? I got a problem, though. Your final answer should be in radians. Anybody remember what 60 was in radians? Pi over? Way to redeem yourself. So that's pi over 3. The reference angle here is pi over 3. So how can you find that r value now? I'm sorry, the theta value. So this is equal to pi over 3. How do you find the whole angle now? This is what we did up here. How do we find that whole angle? We did 180, but it's in radians, so pi minus pi over 3. You guys told me you were comfortable doing that. What do I change this to make a denominator of 3? 3 pi over 3 minus pi over 3. What's my angle? 2 pi over 3. So the final coordinate, 2 comma 2 pi over 3. Always use tangent. Always use tangent because you already have the opposite and the adjacent. Take a quick breather. Questions there? All right, one more. That's it, one more. 3, negative 1. Go ahead, graph it. 3, negative 1. Fellas, you all right where this one is? Yeah. All right, just checking. There's 3, negative 1. Quadrant 4. All right, help me find the r value first. Remember, make a right triangle. What? What do you want? I always want you to do the Pythagorean theorem, but I need values though, Matt. Where? Yep. So that's a length of 3, and this is a length of negative 1. So r squared, the r value squared, is going to be equal to 3 squared plus negative 1 all squared. Make sure you use parentheses if for some reason you need to know what negative 1 squared is on your calculator. We got r squared equal to 10. So the r value is going to be, and you can just leave it like this, square root of 10. Don't give me any sloppy decimals. All right, the angle now. Okay, to find the angle, we always use tangent. What's the opposite side here? My opposite side? Negative 1 over 3. Go ahead in your calcs. Second tan, negative 1 over 3. And go about the nearest degree, okay? Make it easy on us all. Go ahead, the nearest degree. So this is about 18 degrees. 18 degrees. Quick problem, it's got to be in radians though. Final answer has to be in radians. How do I convert to radians? I know it's been a while. Multiply it by pi over 180. Nice. Multiply it by pi over 180. All right, no big deal. Everyone go to your calculator, figure out what 18 over 180 is simplified for me. What is that simplified? 18 over 180. Pi over 10. All right. Who's digging deep here now? Now that that's the reference angle, pi over 10. Woo! How do you find the big angle? That's the one I need to put into my coordinate now. You got it. You got it. What do we have? 2 pi. It's in the fourth quadrant. 2 pi, add it or subtract it to pi over 10. Minus pi over 10. What do I change that 2 pi to? Be careful. Don't give me 10 over 10. 20 pi, because it's got to equal to 2 pi. So what is that angle there in the fourth quadrant? 19 pi over 10. So final answer here, that polar coordinate is radical 10, comma, 19 pi over 10. Anything there? I know this is becoming a kind of like a theme here, but we'll be in the